Hi everyone, Quantum is back again for our case study presentation related to linear programming that we discussed in our previous group presentation. By the way, my name is Liza Jane Tan, together with the rest of the members of Quantum, Ms. Clichelle Pudet, Ms. Clarabella Boris, Mr. Jerry Gamayan, and Mr. Jishis Lam. We would like to present to you our case study entitled Mexicana Wireworks. But before we're going to get into every detail of Mexicana's data and before diving into addressing Mexicana's issue or problem, let me just give you a little overview about the company's business operation and the current problem that they are facing. So this is the overview of the company, its operation, and the business problem it's facing. Mexicana Wire Winding Incorporated is a subsidiary of a Texas firm, Westover Wire Works, producing wire windings used in making electrical transformers. This problem has a good fortune of booking more orders than they can fill. The company has ordered new equipment to help in the long term, but they still have a short term issue. In addition, the company is refinancing long term debt and needs profits to be as high as possible to counteract the effects of this refinance. The problem is to select the orders that will make the company the most profitable for the month while keeping the customers happy by filling their minimum requirements. Ron Garcia, a newly hired management trainee of Mexicana, is given the task to help management resolve their problem by figuring out which order to run and which to back order to maximize the company's profit. Garcia, surprised and apprehensive about the high profile assignment, asked for the company data to start working on the given task. Now, so the company provided Ron Garcia this data. Now, this table shows the list of orders placed for the month of April. Now, on the left column, you can see the product types, which I label product A, product B, C, and D. And on the right side, you can see the number of units ordered per product. Now for product A, there are 1,400 units ordered. Product B, 250 units ordered. C, 1,510 units. And D, 1,116 units. Note, Vivian Espana, who is actually the general manager of Mexicana, has given her word to a key customer that we will manufacture 600 units of product W007X or the product D and 150 units of product W0075C or product A for him during April. Now, and because month of April is coming up, and with these orders, the question is that what can be done in order for the company to be more profitable in the short-term period. Now, the second table actually shows the standard cost per unit of product type. Now, you can see here the cost of material, labor, overhead cost, and the selling price. Now, for product A, cost of material is $33, labor cost $9.90, overhead cost $23.10, and the selling price each unit of product A is $100, so on and so forth. Now, with this table, we can actually compute the profit by deducting the total cost, the total standard cost, the material, labor, overhead cost from the selling price, in which for product A, it gets $34 profit when sold per unit. For product B, $30 profit. For C, $60 profit. And for D, $25 profit. Now, average output per month is 2,400. Average machine utilization is 63%. Average percentage of production set to work department is 5%, which are mostly from winding department. And average number of rejected units awaiting net rework, 850, which are mostly from winding department. And this data also are given to Ron Garcia This table here shows the plant capacity in hours for every department. Now for drawing department, um, the maximum capacity in hours is 4,000. Extrusion 4,200 hours. Winding 2,000 hours. Packaging 2,300 hours. And then note, inspection capacity is not a problem. We can work overtime as necessary to accommodate any schedule. Now there's also a data here for bill of labor hours in hours per unit. Now you can see here, each unit of product A takes 1 hour at the drawing department, 1 hour at the extrusion department, 1 hour at the winding department, and 1 hour at the packaging department, so on and so forth. Now with this data, we can use those data in formulating the LP problem. Okay, first we need to find the decision variables. And we have 4 decision variables. Product A, which is equal to the number of units of product, W0075C to be produced. B, is equal to number of units of product, W0033C to be produced. C is equal to number of units of product, W0005X to be produced. And D is equal to number of units of product, W0007X to be produced. Now, next step is to find the objective function. Now, in finding the objective, like I mentioned in our previous group presentation on linear programming, to find objective is to figure out what the company really wants to maximize or minimize. And in this case, Mexicana wants to maximize its profit. So objective, maximize profit, and this is the mathematical expression of the objective. It's $34 times the number of units of product W0075C or product A to be produced, plus $30 times product B. It's number of units of product W0033C to be produced, plus $60 times number of units of product W005X to be produced, plus $25 times the number of units of product W007X to be produced. Again, $34 A plus $30 B plus $60 C plus $25 D. That's the mathematical expression of the objective. We call it objective function. Next is we need to define the constraints. Now the first constraint is the hours of drawing time used cannot exceed 4,000 hours. Drawing department's total time used is 1 hour per unit of product A times number of product A produced, plus 2 hours per unit of product B times number of product B produced, plus 1 hour per unit of product D times number of product D produced. Now, first constraint, therefore, is drawing time used is less than or equal to the maximum drawing hours, or 1A plus 2B plus 0C plus 1D is less than or equal to 4,000 hours of drawing time. So that's our first constraint, this one. The second constraint is the hours of extrusion time used cannot exceed 4,200 hours. Now, extrusion department's total time used is 1 hour per unit of product A times number of product A produced plus 1 hour per unit of product B times number of product B produced plus 4 hours per unit of product C times number of product C produced plus 1 hour per unit of product D times number of product D produced. And in other words, our second constraint, extrusion time used is less than or equal to maximum extrusion hours, or 1A plus 1B plus 4C plus 1D must be what? Less than or equal to 4,200 hours of extrusion time. Now, let's proceed to the third constraint. Third constraint states the hours of winding time used cannot exceed 2,000 hours. So, winding department's total time used, you have to add 1 hour per unit of product A times number of product A produced plus 3 hours per unit of product B times number of product B produced. Oh, this is not first constraint, but this is third constraint. I'm sorry. Why is it first constraint? Okay, so this is supposed to be third constraint. So, winding time used in our third constraint must be less than or equal to the maximum winding hours, or 1A plus 3B plus 0C plus 0D must be less than or equal to 2,000 winding hours of winding time. And fourth constraint, the hours of packaging time used cannot exceed 2,300 hours. So, packaging department's total time used is 1 hour per unit of product A times number of product A produced plus 3 hours per unit of product C times number of product C produced plus 2 hours per unit of product D times number of product D produced. And our fourth constraint, again, this is not second constraint, that's typographical error. I probably just copied and pasted it and I forgot to change it. Okay, but this is my original work. Okay. So here's our fourth constraint. Extrusion time used must be less than or equal to maximum packaging hours, or 1A plus 0B plus 3C plus 2D must be less than or equal to 2,300 packaging hours. Now, we finally arrived at Mexicana's final mathematical problem, which may be stated as maximize profit $34 A plus $30 B plus $60 C plus $25 D, subject to the following constraints. 1A plus 2B plus 0C plus 1D must be less than or equal to 4,000 drawing. That's for the drawing. Second constraint, 1A plus 1B plus 4C plus 1D must be less than or equal to 4,200 for extrusion. 1A, this is our third constraint, 1A plus 3B plus 0C plus 0D must be less than or equal to 2,000 for winding. And 1A plus 0B plus 3C plus 2D must be less than or equal to 2,300 for packaging. Now, we will then solve this Mexicana's final mathematical problem using QM for Windows and not graphical method, because this involves more than 2 decision variables. So let's hear now from Ms. Who's next to report? Ms. Glishal Booted for the solution to this mathematical problem using QM for Windows. Thank you.
Here is a summary of data from the Mexicana Wireworks case that we will be using to come up with a recommendation of Ron Garcia on what units or what products are to be produced in April in order to achieve a maximum profit. So to begin, we have to calculate the profit for each product, such as profit is just revenue minus expenses. So selling price minus material cost minus labor cost minus overhead cost is profit. So we just have to copy the formula here. And now we have profit of 34, 30, 60, and 25. We can now arrive to an objective function in terms of P such that P1 is equal to 34, P2 is 30, P3 is 60, and P4 is 25. We just input the value of objective function here, such as 34, 30, 60, and 25. For the constraints, we have listed 6. We take into account the order constraints of 2 key customers as committed by Vivian España, such as 600 units for a W007X product only and 150 units for W0075C product only. So now that our data is ready for the QM computation, we now click Excel QM, then look for the linear programming in the drop-down list. So it will direct us to a spreadsheet in the decision table. So we simply title it as Mexicana Wireworks case, and we specify the number of constraints of this problem. There are 6 constraints of this problem and 4 variables. The objective is to maximize profit, so we click maximize, and then the sheet name, it could be anything, so just put the MWO, a abbreviation for this one. So we click OK. As we click that OK, it will direct us to a ready spreadsheet. So this spreadsheet is, we name it Mexicana Wireworks. So we change the variable name and the constraint name first before inputting the values here. So we just have to copy the variable name here. We copy that one, and also the constraint name. Copy. Now we also copy the values of objective function such as 34, 30, and 25 here. We also copy the value for the constraints here, and also for the value of the RHS, the right hand side constraints. As we can see here, our objectives are not the same for the key customers, so we also change the sign here. It's greater than sign, so we change it greater than sign. So our data input is complete. We are now ready to click the Run Excel Solver. So once we click this one, it will give us an answer for the number of units produced in April and the maximum profit. So once I click this one, it will give us an answer. With these results, Ron Garcia can now recommend that in order to produce a maximum profit of 61,400, the company will only manufacture 1,100 W075C product, 300 W033C product, 600 W0007X product, and not to produce W0005X product.
Okay, so hello everybody. Let's now proceed to the discussion questions of the case study Mexicana Wireworks. So for the first discussion question, what recommendations should Ron Garcia make with what justification provide a detailed analysis with charts, graphs, and computer printouts included. Okay, so before we can make any recommendations, we first need to identify our data, or what do we have. Okay, so we have our April orders. We have 4 products, and um, we have a different number of units from each product for each product. And there is also a note given provided by the problem. The note is Vivian España has given her word to a key customer that we will manufacture 600 units of product W007X and 150 units of product W0075C for him during April. Next data, we have the standard cost for each product. So we can see that the 4 products are here. For to calculate the standard cost, we add the material, labor, and overhead. We can also see the selling price of the product. Okay. Next, we have our selected operating data. Average output per month is 2,400 units. Average machine utilization is 63%. Average percentage of production set to rework department 5%. Average number of rejected units awaiting rework is 850. Next, we have our plant capacity, or Rs. So, drawing 4,000, extrusion 4,200, winding 2,000, and packaging 2,300. We also have a note here. Inspection capacity is not a problem. We can work overtime as necessary to accommodate any schedule. And for our last data, we have bill of labor, or Rs per unit. So we have here the 4 products again, and we can see the total number of Rs. So our objective here really is to maximize profit. And to maximize our profit, first we need to identify the profit for each product. So for the 4 products, I've decided to label them product A, B, C, and D, as you can see in the table, because the product name is just too long to mention. Okay, so to get the profit, we first need to get the total cost, and that's to add the material, labor, and overhead for each product. So that's $33 plus $9.90, and for the overhead we add $23.10. The total cost for this product A is $66. Then we subtract it to the selling price of $100. That's how we get the $34 profit for product A. And we basically do the same for product B, C, and D. We add the material, labor, and overhead. Total cost 50. Then minus selling price minus total cost equals 30. Okay. So for product C, we have a $60 profit, the highest among all products. And for product D, we have a $25 profit. So basically our maximized profit, this will be our initial equation. So profit equals 34A plus 30B plus 60C plus 25D. This will be our initial equation. Next, we go back to our bill of labor table and the April orders. So we have to take note that there was a note in the April order. There is a key customer that we will manufacture 600 units for product D. That's the 7X, and 150 units of product A. That's the 75C. So that's for April. After adjusting to limitations, the subjects to constraints are for drawing. We have for drawing we have product A, B, and D. There's no product C because, as you can see, for the bill of labor, it's 0. Or okay, so for extrusion, we have all 4 products and 4 R's for product C. And for winding, we have 2 products only. That's product A and B. 3 R's for product B. And for packaging, we have 3 products, A, C, and D, and 3 R's for product C, 2 R's for product D. And we need to get the target of 2,000 or less than or equal to 2,300. Same goes for the others, drawing, extrusion, and winding. That's less than or equal to 4,000, and the rest. Next is already mentioned this, the key customer, the note. So the target is more than or equal to 150 for product A, and for product D, that's more than or equal to 600. And the rest are the April orders for each product, or rather the units. Okay, so now that we've gathered all our data, we add them all to Excel. As you can see, this 75 is product A, product B, product C, and product D. The function is use sum product to add all this. So once you solve that, you should arrive at this as a result. So the left hand side should be for drawing 2,300, for extrusion 2,000, same with winding 2,000. Packaging is 2,300, and for the first key customer, the 600, that was product D, and for the 1,100 for the key customer, that's for product A. Okay, so now we go back to the question. What recommendations should Ron Garcia make, with what justification? Okay, so in April, the following quantities of product should be produced to achieve optimum profit, which will satisfy all limitations. For product A, that's 1,100 units, which is more than 150. For product B, that's 250 units. Product C, 0 units, and for product D, 600 units. The optimum profit is $59,900 US. So in conclusion, Ron Garcia should make recommendation to make the remaining hours of intrusion and drawing unused. This recommendation of Ron can be justified as packaging hours will be fully employed. The remaining hours of intrusion and drawing will be unused. And that is it for my answer. Thank you.
For discussion question number 2, discuss the need for temporary workers in the drawing department. Looking at the need for additional temporary workers in the drawing department, Ron determined that by adding more workers, it will reduce labor time, yet it will increase the labor cost. Given the quantity will still be the same, it will only increase cost and decrease profit due to increase in production cost. So additional temporary workers are not required in the drawing department since the labor hours are underutilized due to lack of winding and packaging hours. Instead, it is recommended that the company hire extra workers for both winding and packaging departments.
This is the discussion question number 3. Discuss the plant layout. The plant layout is not optimum. When we install the new equipment, an opportunity for improving the layout could arise. Exchanging the locations for packaging and extrusion would create a better flow of our main product. Also, as we improve our quality and reduce our rework inventory, we could capture some of the space now for rework, storage, and processing and put it to productive use. The plant layout should be in the order of the process to ensure smooth production process. The suggested process sequence: drawing, extrusion, winding, inspection, packaging. After the inspection, goods that pass the quality check will be packaged and sent to the storage area. Defective product will be stored separately until it can be reworked.